Hi guys, and welcome to Learn Extra Live. As you know, it's grade 10 and Liesl is with us and she'll be taking today's lesson. What are we chatting about today?
Well, in today's lesson, grade 10s, we are going to have a look at algebraic expressions. So we'll be having a look at how to multiply out and simplify algebraic expressions. Also those double-decker ones where we add and subtract and multiply and divide. So we'll be revising the rules of factorization along the way as well. So that's what we've got in store for you tonight.
I think it's very exciting because I know there have been a whole bunch of you on the Facebook page asking us to tackle this. So guys, keep in touch. Go to www.learnextra.facebook.com. Also chat to us on Twitter @LearnExtra. We're going to go to a quick break and we'll be back with you shortly. See you now. Hi guys, and welcome back. Guys, get chatting to me on Facebook or Twitter. Treasure, I see you're watching. I wanted to know, Buntle said that she was going to be watching again this time. I've already asked you on Facebook. Buntle, are you tuning in because you were here last week? Okay guys, I think the best thing to do is get straight back to Liesl. Let's work through the question. If there's anything that you're not getting or you're struggling with, please let me know on Facebook or Twitter. That's facebook.com/learnextra, and that's with an XTRA. Also chat to me on Twitter @learnextra, also XTRA. Guys, drop me a line, even if it's just to say hi. Liesl, on to you.
So let's have a look at another such expression. It's in a way kind of similar to the one that we did previously, but in the previous one, the only type of factorizing that we had to do was taking out a common factor. Now, obviously factorizing gets a little bit more exciting than that, so I've picked one that has different sorts of factorizing in. Right. So if I have a look at my expression, at the numerator on the left-hand side, I've got p cubed plus q cubed. Now that is something very, very important that's back in the syllabus, and it's called sums and differences of cubes. Now before I carry on with this question, I'm just quickly going to take you guys through the rules for factorizing sums and differences of cubes. So let's say we have an expression x cubed plus y cubed, right? This is a sum of cubes because there's a positive in between and both of the letters are cubic. If I factorize a sum of cubes, what I do is the following. I make one small bracket and one larger bracket, and I then ask myself, what is the cube root of x to the power 3? The cube root of x to the power 3, of course, is x. Then I ask myself, what is the cube root of y to the power 3? And that, of course, is y. And in between the two terms, I put a plus, exactly the same as my original expression. So that is what's going down in the small bracket. Now, I need to figure out what I need to write over here. So what I then do is I have a look at my first term and I say, what is x times x? X times x is x squared. And I put that over there. Y times y, y squared, and that's my final term. Then I say x times y, so I'm multiplying them with each other, is xy, and my bracket has a minus in between the first two terms and a plus in between the second two terms. Now guys, this is a general rule that can be applied to any sum of cubes. Let's quickly also just deal with the difference of cubes. So a difference of cubes would be if I had something like x to the power 3 minus y to the power 3, right? Difference, the word difference means to minus, so that's all good. And again, they are cubes. So let's have a look at what I'm going to do. Now, if I factorize a difference of cubes, again, I am going to need a small bracket and a larger bracket. And the same rule applies again. I say to myself, well, what is the cube root of x to the power 3? And that would be x. And what is the cube root of y to the power 3? That would be y. And again, my sign stays the same as the original expression. So where the sum of cubes had a plus in the small bracket, the difference of cubes has a minus in the small bracket. Then I go about finding the terms for my bigger bracket in much the same manner. I say, right, What is x times x? That's x squared. What is y times y? Y squared. What is x times y? That's xy, and both signs in this bracket is positive. Right, so this is a rule that you need to know whenever you are factorizing any form of a sum or a difference of cubes. So now that you've had that little lesson, we're going to carry on back to our expression and see how we can apply our rules for the sum and difference of cubes. Right. Now I can't seem to move my question, so I'll have to write it up again. Right, so we had p cubed plus q cubed. That was all divided by p to the power 2, multiplied by 3p minus 3q divided by p squared minus q squared. Right. So the reason why I showed you guys how to do the sum and difference of cubes is because p to the power 3 plus q to the power 3 is a sum of cubes. But now remember guys, it doesn't just have to be p's and q's or x's and y's. If I have something like x to the power 3 plus 8, because 8 is a cubic number, 2 times 2 times 2, that would also be considered a sum of cubes. Right, so let's carry on and have a look at our first bracket. My first bracket will be p plus q. Then I have to write a larger bracket, which is all very fine. That is going to be p squared minus pq plus q squared. Right, so I have now dealt with the numerator over here. There's nothing I can do at this stage about the p squared, so I just leave it like it is. Now, if I have a look at the second term, I've got 3p minus 3q, and over there, much the same as the previous one, I can take out a common factor, and my common factor, it's screaming from the hilltops, will be 3. Right. And then in the denominator, I have a difference of squares, and that, of course, factorizes p minus q and p plus q. Now, remember, guys, I have now spent a good minute or two just factorizing my expression. That is the first thing that you do. Please do not cancel over a plus and minus. It is just not allowed. But now that I have factorized, I am allowed to cancel. So let's see what does cancel. This p minus q and that p minus q over there cancels quite nicely, so that's wonderful. The p plus q and the p plus q cancels, and I am left with 3. My big bracket, which is p squared minus pq plus q squared, and that is all divided by p squared. Right, so you guys will see that you have to be able to factorize to simplify algebraic expressions. That is why in grade 9 a lot of time is spent on factorizing, so that when you get to this point in your grade 10 career, that you are able to apply those rules. Now, before I hand over to Indiana, just a reminder that after the next break, what we're going to be doing is having a look at similar questions, but when there is a plus and a minus in between the terms. So, Indiana, any interest out there?
Well, let's have a look here. There's a lot of people joining in. Thanks so much, guys. Anele, can't wait to see you in the grade 11 session. But guys, don't forget, grade 12s, you can join in for the grade 10, 11, and 12 sessions. So this could be, sure, a 3-hour affair for you guys if you're tuning in. But that's okay, because we've got some exciting things happening. Perhaps even after this break, we may be even giving away a prize. Did the producer tell us that we need to go to break?
I think so, yes.
Okay, guys, I hope you're all tuning in. And guys, don't forget to chat to me on Facebook and Twitter. The more you get chatting, you never know. Sometimes you ask a question and it seems silly, but actually one of your friends are wondering the exact same thing. So get those questions in, guys. There's no such thing as a silly question. Now for a break, and we'll see you in 2 minutes. Bye. welcome back, Mindsetters. Thanks so much for joining, and thank you so much for sending all your questions in. Guys, this is what I'm going to show you how this works. So we said, guys, send in your questions, tell us what you're not understanding. And we had Simtembile who wrote in, and he said, hey, okay, I'm struggling to understand algebraic fractions and the sum and difference of two cubes. And he gave us an example. So I think we're going to get straight to that example, Liesl, and see if we can help you out, Simtembile.
All right. Okay, it's a lovely example that Simtembile sent through. It's not a whole algebraic fraction, but it's definitely a factorizing part of it, and there might be other people struggling as well. So what we have here is p to the power 3 minus 125 q to the power 6. Now, this is definitely a difference of cubes, and because 125, of course, 5 times 5 times 5 gives me 125. Right. So, Simtembile, I hope you're watching. We're starting off with our small bracket, and then we're moving on to our bigger bracket. And the first question that I ask myself is, what is the cube root of p to the power 3? And of course, that is p, right? Then I ask myself, what is the cube root of 125 q to the power 6? So what times what times what, in other words, will give me 125 q to the power 6? And the answer is 5q squared. Because if I multiply 5q squared with another 5q squared with another 5q squared, I will get 125 q to the power 6, right? So the sign in between is going to be a minus, and with that, I've got my first bracket sorted out. Now I've got to deal with the second bracket. Remember, for a difference of cubes, both the signs in the second bracket are then positive. So now I say, what is p multiplied by p? So I multiply the first term with itself, and p multiplied by p is p squared. Then I look at the second term in my small bracket and I say, what is 5q squared multiplied by 5q squared? Well, that of course is 25q to the power 4. And then I multiply the two terms with each other. So I say 5q squared times p, and that then gives me 5pq squared. Right, so Simtembile, that's how you go about it. Very, very systematic. Apply the rule to figure out your first bracket, and then you go p times p to give you this one, that times that to give you that one, and you multiply them with each other to get the middle term. So we hope, Simtembile, that this has been helpful. Definitely quite tricky in the beginning to understand how to factorize a sum and a difference of cubes, because it's so different from a difference of squares. Right, so as I promised you guys before the break, we said there were two types of algebraic expressions. The first two questions that we had a look at tonight, they were between the fractions, they were multiplication or division signs. And we dealt with those in a certain way. We said you've got to factorize, and then you can cancel, and so forth. Now we're going to have a look at algebraic expressions where there's pluses and minuses in between the two terms, and this unfortunately makes it ever so slightly more complicated. So I'm going to start with a simple one though, because we don't want to start out with something difficult. The instruction in a question such as this will be to simplify. Simplify, and there is our question. Right. Now the steps that we have to follow when we're dealing with a question such as this one is slightly different. The first thing that we have to do, we also have to look where the factorization isn't perhaps possible. In this question, I think you guys will agree that I can't factorize that. It's already as simple as it's going to be. Now the next thing that we need to remember, if there are plus or minus signs in between our terms, is that we need to get a lowest common denominator. So a lowest common denominator would be the smallest number that both of the terms go into. Now just to recap a little bit to your earlier years, if I had 2 over 3 minus, let's say, 2 over 6, and I was asked to get an LCD, or a lowest common denominator, that means I had to find a number into which both 3 and 6 go into, and that number, of course, in this case, would have been 6, because 6 goes into 6 and 3 goes into 6 as well. Now the concept is very much the same now, except that we're dealing with some variables. So now I've got to get an LCD between t minus 3 and t minus 2 and t minus 3. And of course my LCD is going to be both of those. So I'm going to write here t minus 2, t minus 3. And what I'm going to, okay, so t minus 2, t minus 3 is my LCD, and I'm going to do the following. I'm going to say, so maybe just write there LCD. Right, so t minus 3 and t minus 2. Now I'm going to look at this first term, and I'm going to say to myself, okay, well my first term has now disappeared, so please come back, first term. I'm going to write it up again. Indiana, I'm not having a very good day with the technology today. So there's the 5 and the t minus 2 minus 1 over t minus 3. Right, so we've already said that our LCD is t minus 2 and t minus 3. So now I have a look at my first term, and I say to myself, what is my first term missing in terms of the LCD? My first term has got the t minus 2, so that's all very fine. It doesn't have the t minus 3. So what I need to do to compensate is say 5 multiplied by t minus 3. Right? And then I have a look at the next term, and I say, well, I've got negative 1 over t minus 3. What is this one missing? It is missing the t minus 2. So I'm going to say minus 1 bracket t minus 3. And in this instance, boys and girls, the brackets are really, really important because it helps you to remember to multiply or distribute that negative into all of the other terms. That's really important. So now I'm going to simplify by multiplying out, and I'm going to say 5 multiplied by t is 5t. 5 multiplied by negative 3 is negative 15. Minus 1 multiplied by t is negative t. And minus 1 multiplied by minus 3 is positive 3. All over my LCD, which is t minus 2 and t minus 3. Now the only thing now remaining for me to do is to collect my like terms in my numerator, and then I am done. So let's do that quickly. Like terms. So I've got 5t minus t, so that gives me 4t. Not 40, 4t. And then I've got negative 15 add 3, so that gives me negative 12. And in fact, I've just noticed that something else that's interesting has happened here. Remember, if they tell us to simplify, we have to simplify all the way to the end. We've got to make it as simple as possible. And I can also take out a 4 at the top here. So I can take out 4 from 4t, I'm left with t. If I take out 4 from negative 12, I'm left with 3. And something lovely happens. I can now cancel 2 of my terms. So look at that. That one cancels with that one. And my final answer is quite simply 4 over t minus 2. But now watch out, boys and girls. Do not be tempted to now go crossing out the 2 and the 4. Remember, crossing out over a plus and a minus sign is a sin. Right, so let's quickly talk about the steps that we followed again. You have to start out the question by checking whether you can't perhaps factorize. In this case, I didn't have to, so that was all fine. Then you've got to decide on your LCD. You've got to do your multiplication, gather your like terms, and make sure that you've got everything as simplified as possible. In some cases, I think the questions with the plus and minus signs in between are slightly more complicated, or they certainly take a little bit longer than the ones with the times and the divide in between. Indiana, what's happening on Twitter and what's happening on Facebook?
There's quite a bit. Well, Spakazi says thank you so much for helping me today because she's writing a test tomorrow. So she said she's going to learn lots today. So hopefully, it's because you're going to ace that test tomorrow, lady. What else is happening? Let's have a look. Treasure has just a little question that I thought maybe you could answer just quickly. Verbally, what is the difference between expressions and equations?
Okay, what's the difference between an expression and an equation? That's a very, very good question, because the way in which we handle an expression is different from how we handle an equation. An equation has an equal sign in, Treasure. So if you have an equation, that allows you to do all sorts of cool things. Like you can just multiply through with the same number throughout. You can divide through with the same number throughout. So it gives us a lot of freedom. There is an equals. However, an expression is what I'm dealing with today, and it's not equal to 0. So I can't go doing the same thing throughout. So the main thing that we're looking for is that equal sign. And the moment there is an equal sign, it is called an algebraic equation, and it does make it slightly more simple to answer. Okay? Right,
That's
guys?
awesome.
What about doing another question, perhaps? What do you think, Indiana?
Yeah, let's do another question, and then we're going to go to a break straight after that. But guys, I have a surprise for you. I know that we're almost halfway through the show, so I might as well let you guys know now. I don't have it with me right now, but we're going to be giving away a calculator today. Hey, Liesel? We're going to be giving away not only in the grade 10 show, but also in the grade 11 and the grade 12 show. So that's 3 calculators today. So guys, what I'm asking you now on Facebook and on Twitter is to just, give us a holler, tell us that you're watching, let us know what grade you're in, let us know how Mindset has perhaps helped you, and also any questions you may have so far. Liesel, back to you.
All right, now the next question is a very fun little question. Now, our teachers, boys and girls, have cottoned on to you guys. We know that you guys use your calculators whenever possible. Now, this question specifically says you must evaluate and find the answer to the expression without using a calculator. So let's have a look. They say evaluate, and then we have got x to the power 3 plus 1 over x squared minus x plus 1. So now, what they say to us is evaluate if x is equal to 7,85 without the use of a calculator. Now, can you guys see that if you were to cheat and use your calculator, we'll be on to you in a second, but anyway,
Teachers know, hey? Teachers know.
We learn quickly. 7,85 is a decimal. So if you were to do this just by substituting in the 7,85, you'd have to know what 7,85 times 7,85 times 7,85 is. Now, guys, I've been doing maths all my life. I don't know what that is. So the trick is here to once again get you guys to factorize so that things become a little bit simpler. So this really isn't a difficult question, but I thought it was quite a cute question. Right, so now the first thing you should be thinking about is that in my numerator, I have got x to the power 3 plus 1, and that is a sum of cubes. So I'm going to factorize that sum of cubes. Let's do that. So x to the power 3 plus 1 factorizes into x plus 1 would be my small bracket. Remember, I ask myself, what is the cube root of x to the power 3? That's x. What is the cube root of 1? That is 1, and the sign is the same as the original expression. So that's why that is a plus. Then I move on to my bigger bracket. And remember, to find out what's in my bigger bracket, and I'll say, what is x times x? X times x is x squared. And what is 1 times 1? 1 times 1 is 1. And then what is 1 times x? 1 times x is x. And remember, the second term in my bigger bracket is negative if it's a sum of cubes. Now, this is all divided by, surprise, surprise, exactly the same expression. So what now happens is this cancels with this, and you can actually give me the value of that expression without using a calculator, because of course, if x is equal to 7,85, I now just have to calculate what is 7,85 plus 1. And any banana can do that. That is, so it was 7,85 plus 1, so that's 8,85. Very, very clever little question designed to oust you if you're going to cheat and use your calculator. So even though we love the calculator, there are times where we have to do our thinking ourselves. Right, Indiana, what are our students saying, and are we ready to go to a break?
Fantastic. Okay, guys, I think that we are nearly ready to go to a break. Before that, I'm going to jump in and ask Lisa a quick sneaky question from Shandu. Hopefully it's a quick one like the last one. What is the difference between squares and a perfect square?
Between squares and a perfect square?
Yes, between...
that's a bit of an odd question. I think
you might be a bit confused.
It could take on many meanings, but let's just have a look. A square number would be a number such as 16, which we can write as... let's just get our pen there.
Oh, shame. Sorry, Lisa, it wasn't
No,
the
it's
quickest
fine.
question.
It really isn't. 16 can be written as 4 times 4. So I say that 16 is therefore a perfect square. However, if I have an expression such as x squared plus 4x plus 4, that is also a perfect square because I can write this as the product of two binomials that are identical. So that x plus 2, x plus 2. So I get a square number, and usually I would say that a perfect square would refer to an algebraic expression that can be written as one thing times another thing that's identical. Right.
Fantastic. Okay, guys, let's go to a break. Guys, don't forget, we're giving away a calculator today. After this break, I'll be able to show it around and swing it around here. Yeah, so get chatting to us. Just let us know if there's anything you're struggling with. And I know a whole bunch of you guys have said that you're writing grade 10 tests tomorrow. Guys, how many more of you are writing tests tomorrow? Let us know. But we'll see you after the break. Welcome back, guys. Finally, I have proof and I have evidence that we are giving away a calculator today. So all you need to do is join our Facebook page, www.facebook.com/learnextra, and that's with an XTRA. Also chat to me on Twitter, and that's @learnextra. My name is Indiana, and I'm here chatting to you guys behind the computer. So if there's anything that Liesel's going over that you don't understand, please pop me a line, whether it's on Twitter or Facebook, and hopefully we'll get it answered. But in the meantime, get commenting, get posting, but most of all, get listening to what Liesel has to say. Liesel, over to you.
Right, guys. Now I'm going to do another question that involves a plus and a minus between my algebraic expression. Something a little bit more complicated than what I did just now, because I think most of you guys will agree that the question that I did just now is actually quite simple. And then after this question, I'm also going to be doing an exponents question, which isn't part of algebraic expressions, but Natasha did a lesson on that last week, and Mpo phoned through wanting me to help him with that. Right, so let's have a look at this question. Again, the instruction will be to simplify, and I have got a squared minus 4ab plus 4b squared, and then plus my following term, a squared plus 2ab plus b squared, and all of that is divided by a to the power 3 minus 8b to the power 3. Right. Now, guys, what I said to you guys just now is before we get our LCD, what we need to do is we need to factorize. That is really very important because you can simplify the question quite significantly by just doing a bit of factorizing. Now, in the previous question, it wasn't actually necessary, but in this one, it is going to be. So let's have a look at what sort of factorizing I can do over here. It looks to me as if this expression, a squared minus 4ab plus 4b squared, is, in fact, a perfect square. So put my equals over there. Let's have a look. Two brackets, perfect square trinomial. A and A a minus and a minus, and a 2b and a 2b. Right, so two identical brackets, a minus 2b. Remember, you can always check whether you factorized correctly by multiplying out again. A times a is a squared. Negative 2b times negative 2b is plus 4b squared. I get a minus 2ab in the middle and a minus 2ab on the outside, so I'm bang on the money. Right, let's have a look at our second term. Now remember, at this point I'm just factorizing. I'm not cancelling out anything.
I have a question, Lisa, while you're on it.
Yes.
Bobby has a question that might have to do with this as well. He says, he always tends to divide instead of cancelling or factorizing. How do I know when not to divide in an algebraic fraction?
Okay.
So maybe when we get there, you can
Bobby, the trick is it doesn't matter which type of question it is, whether it's got a times and divide, which is one type, or a plus and a minus, the other type. Step one is always to factorize. You should immediately, when you look at the question, think, how can I factorize? Can I take out a common factor? Is it perhaps a trinomial, the difference of two squares, or a sum or a difference of cubes? You've got to make super duper sure that you factorize as far as possible in the first step, regardless of what type of question it is. Then, if it's a times divide type, you can start cancelling, no problem. If it's a plus minus type, you'll be getting your LCD. So factorize first, FF, Bobby. Right, let's carry on with this one. Now, I'm going to factorize first, and I'm checking this out, and I'm seeing that this is, again, a perfect square. So that's very cool. This is going to factorize a plus b and a plus b. Remember, again, we can check. We can say a times a squared, correct. B times b squared. B times a is ab, and another ab. That gives me the 2ab, so I am correct, right on the money. Now, in my denominator is what we spoke about earlier today. We've got a difference of cubes, because, of course, a to the power 3 is cubic, b to the power 3 is cubic, and 8 is a cubic number, because 2 times 2 times 2 is 8. So let's get on with the business of factorizing. Small bracket, bigger bracket, although I don't have a lot of space, so I start off by saying, what is the cube root of a to the power 3? That is a. Minus, remember the sign stays the same, and what is the cube root of 8? That is 2. And the cube root of b cubed, that's b. Right. Then on to my second bracket. My second bracket is going to be a times a, which is a squared, right? Negative 2b times negative 2b, which is 4b squared. And then I multiply the 2 with each other, and that is plus and 2ab. Right? If I got it right, it looks like it. Sorry, guys, I'm just ever so slightly running out of space, but that is my factorization. Right. Now what we need to do is we need to get on with the business of finding our actual LCD. Now this question is actually a little bit more complicated than I initially intended, but that's fine. Let's have a look. I have got a minus 2b and a minus 2b in my first expression, so I'm going to need a minus 2b squared as my LCD. I've got a minus 2b in my second one, so the squared a minus 2b will already take care of this one, but I also now need to include this into my denominator. Right. Okay, so I'm going to get on with the business of writing my LCD. And my LCD, and I'm putting my equals over here, is going to be a minus 2b. Everything squared as well as a squared plus, my handwriting is terrible there, 2ab plus 4b squared. Right, then I say to myself, if I look at my first term, what am I missing? Well, my first term has got the a minus 2b and the a minus 2b, so that's fine. But the 1 needs to be multiplied with the second part of my LCD. And because it's just a 1, I'm going to go straight away and just say a squared plus 2ab plus 4b squared. Right. There's a plus sign in between, which also always makes things a little bit simpler. And if I have a look at this part of the LCD, or at this part of the expression, what I am missing is just a single a minus 2b. So it'll be my a plus b times my a plus b times my a minus 2b. Now, of course, this will all need to be multiplied out and simplified. This is quite a tedious process, but I think you guys get the gist of it. Now, we don't have a lot of time left, so I think I need to carry on with the question that Mpho phoned through to us. Now, as I said before, last week's lesson was on exponents, so Mpho's question is on exponents, but it is still an algebraic expression. We are still factorizing, so I still think that that is entirely appropriate. So let's have a look at Mpho's question. Oh my goodness, I'm going to have to change my color pen over here because I don't know what I've done to the board. Let's just see quickly.
Don't worry, you got it?
Yeah, I think we've got it.
Don't worry, that's okay, guys. Guys, don't forget that we've got this amazing calculator that we are giving away at the end of the show. It's happening. I already see a few comments that I'm liking at the moment. Yeah, we're actually going to give this away at the end of the show. In grade 11s and grade 12s, you guys are also going to have your own chance to also win your very own calculator. It is a scientific calculator. It's quite nifty. Yeah, and Liesel, are you ready for us? Is it still
I'm ready for you, but now with the white screen. But
yeah, guys, get chatting to us on Facebook and Twitter.
our point is to try and help Mpho, so
there
I
you
don't
go.
think Mpho minds too much in what color we write as long as we help.
She's
Okay,
fine.
now this is an algebraic expression. It contains fractions, obviously, so it contains exponents, which makes it a little bit more complicated than what we've been looking at before, but nonetheless. Again, guys, the same concept applies. You are not allowed to cancel over a plus and minus. That is highly illegal in mathematics. So what we need to do is we need to take out a common factor. And the common factor that I'm going to take out, usually I try and take out something with the variable exponent. Now, what I can see is I've got a 2 to the power n over there, over here, and in both terms at the bottom. So I'm going to be taking out 2 to the power n as my common factor. However, I have to be very, very careful that I am correct in my leftovers, that I write what is left over in my bracket correctly. So if I take out 2 to the power n as a common factor, from my first term, I have now taken out the 2 to the power n, so I'm left with 3. So that's all very fine, minus. Now, if I look at the second term, I'm going to take out 2 to the power n, but now we must be very careful. That gets, the 2 to the power n gets taken out as a common factor. I am left with 4, but I am also left with 2 to the power negative 2. That is very, very important. So there's the 2 to the power n, that's gone, but this is the bit that you guys are forever forgetting. So 2 to the power negative 2, like that. And probably, Mpho, I would imagine that this is where you went wrong. Now, in my denominator, I will also be taking out 2 to the power n. I am then left with 1 minus. Now, if I take out the 2 to the power n here, I am left with 2 to the power negative 1. Right. So what happens now is quite cool because the 2 to the power n at the top and the 2 to the power n at the bottom cancel out. But guys, notice very carefully, I do not cancel anything until I have factorized. I think that's probably the most important lesson that you're going to learn today, and you'd be surprised. I've got matric pupils who happily and merrily cancel over a plus and minus don't. Now guys, I know that if you at home have the wonderful Casio calculator, what you can do is just type in the remaining things and get to your answer. But it's always nice to know how things work. You never know when you might be stranded on a desert island without a calculator. So let's have a look. Over here I've got 3 minus, fine. And now I need to figure out what's going on over here. This is 2 to the power negative 2. Now if 2 to the power 2 is 4, then 2 to the power negative 2 is 1 over 4, right? Remember that. So 2 to the power 3 is 8. So 2 to the power negative 3 is 1 over 8. So in fact, this 2 to the power negative 2 is 1 over 4 a quarter. So what I have got here is 4 times a quarter. So that's 4 times a quarter, of course, is 1. So at the top, I've got 3 minus 1. And in my bottom part of my expression, I have got 1 minus, and if 2 to the power 1 is 2, then 2 to the power negative 1 is a half. So at the bottom, I've got 1 minus a half. So what does that come down to? 2 at the top, a half at the bottom, and 2 divided by a half is 4. Right, guys. I think I'm going to have to hand over to Indiana so that she can possibly tell us who was the lucky winner of the calculator. Pity I can't enter.
I know, I'm so sorry. Maybe next week, Liesel, when you're not on the show, I'll make sure that you're watching. Guys, thanks so much for tuning in today's show. It's been fantastic, fantastic. Grade 11s, don't forget that you guys are on next. Grade 12s, you guys can just watch all of the shows. But let's quickly do the winner. The winner that we have chosen today for the calculator is Treasure. And the reason why we have chosen Treasure is because this was his comment. He said, "Mindset's rocks. Ever since I've been watching you guys, I'm in top 3 in my class. So guys, keep up the good work, and I'll be watching not only the math show, but all the other grade 10 subjects. Thank you guys a lot." Treasure, I will be sending you...
Well done. What a lovely comment.
I know. Well done, Treasure. I'll be letting you know how you can get your prize on Facebook. Guys, don't ever put out your email addresses or mobile numbers or any of your personal details on the Facebook page. Just wanted to let you know. Okay. So guys, grade 10s, thank you, and grade 11s, we'll be seeing you next. Bye.